Hello, today we're going to do subscripted variables, and all that it means is that we have a letter that is a little bit smaller on the bottom. Now, that is going to be representing on word problems something else. So it's using, instead of X and Y, we use, for example, NN to say the number of nickels and ND the number of dimes. So those things are going to be representing what the word problem is giving us. But right now we're not doing word problems, we're just reviewing how we solve this. Now remember that we solve it exactly the same way that if we had an X or a Y. So what we have to do in this case, I'm going to practice with elimination. It's always easier whenever we have a 10 just to multiply here by negative 10. And that way we are going to be able to eliminate very easily. Remember that if you multiply times negative 10, you have to multiply each one of them times negative 10, and you would get that. And then on the bottom, we are not going to multiply by anything because we already have the positive 10, the ND that we need. And then to do elimination, what we do is that we add these two equations, and we have negative 5NN. These two cancel because it's a positive and a negative 10. And then negative 400 minus 250 is negative 150. And then when we pass the negative 5 to divide, we get positive 30. So again, if this represented the number of nickels, then we would be finding that there were 30 nickels in the bag. Now we always want to find both of them, so we come back to this one in the original problem, and we say, okay, NN plus ND equals 40, and we already found out that NN equals 30, so I can substitute and change that value for 30, and then pass to subtract to find the value of the ND, and then that would be 10. So there would be 30 nickels and 10 dimes, if that were the case. So it's very simple. We are working just like with any other variable, like X or Y, but in this case, we're using NN and ND to get used to using subscripted variables to represent and solve word problems. In the next example, we have a main equation, which is the first one that they give us, and then they give us the value of our M, our W, and then some information about the time. Now remember, R and T, what they're representing is rate and time, and when I multiply rate or speed times time, I get distance. So this is a distance problem, which again, we're going to be working to solve a word problem. But right now, we're just practicing how to solve these equations. So what we're going to do is we're going to change or substitute the values that were given. So the RM is 40. The TM, we don't know. Then we have the RW, which is 60. And the TW, we don't know. Now we can't solve that because we still have two different variables, but we could from here pass one of the variables to be in terms of the other one. So if I pass the TW that is adding to subtract, now I have TM in terms of TW. And so what we're going to do is we're going to change the TM for 5 minus TW. And that way now we have what we need to solve this equation because we have only one variable. Remember that we always get rid of the parentheses first. So 5 times 40 is 200 minus 40 TW plus 60 TW equals to 60. Now I do like terms, and 60 minus 40 is 20 TW. And 260 minus 200 is just 60. The 20 goes to divide, and 60 divided by 20 is 3. Now remember, we were saying that this is time, but since we're not in a word problem, we're just going to say that TW is 3. And to find TM, I have to come back here and just substitute 5 minus 3, which is 2. Because we knew from the beginning, or from the problem, that the TM plus TW equals 5. So that's it. So we found the TW and the TM. In the next section of this lesson 17, we are going to solve geometric problems using systems of equations. So we already did this before using just regular equations, but now since we are using x and y, we have to do a system of equations. So we have to remember everything that we've learned before in geometry and then apply that and create a system of equations or create two equations with that information that we know from previous lessons. So for example, in this case, we have a transversal. Remember, this is the transversal. And then that transversal is creating 8 angles, which are 4 equal and 4 equal. So what we have to remember is that this is 50, but then this is supplementary to 50, so that's 130. And then this guy is going to be the same as 50, and then the 130 is here. Remember how we learned that the transversal creates those kind of angles with two parallel lines. These are parallel lines. So we can create our system of equations by saying what equals what. So in the first one, I can say that 7x minus 2y equals 130 because that's what we see in the drawing. And then we can also say that 5x minus 10y equals 50. And there's the system of equations that we're going to use to solve that problem. So in this case, we have two variables, so we have to use elimination or substitution. I'm going to use elimination because it's easier. If I multiply here times -5, I'm going to change these to +10 and then they cancel. So remember, -5 has to multiply all of the terms on the top. So we're going to get -35x plus 10y equals -650. Then on the bottom, we don't need to multiply by anything because we already have the -10y. And then we're just going to add. When I add these two, cancel the 10 and -10. And -35x plus 5x equals -30x. -650 plus 50, the answer is -600, which again, if we divide, we are going to get 20. And if x equals 20, then we just substitute in one of the originals to find y. I'm going to do it here. So let's say we're going to do 5 times 20 minus 10y equals 50. Using this one here, the original equation, and that's 100. So -10y equals 50 minus 100 that we got from here. So y equals -50 divided by -10, which is 5. So y equals 5, and that would be our answer. Okay, so that's a very simple exercise. Just remember that you use the knowledge that you have from geometry lessons and you apply it by creating equations, and in this case, two equations to solve a system of equations and then find your answer. All right, I'll see you in the next video.